Alright, so this video is going to cover 10.1 and 10.2. They're very closely related, so we're going to just talk about both topics at once. So this one is talking about relationship between two categorical variables, marginal and joint relative frequency. So two categorical variables can be represented with a two-way frequency table. Now let's remember that categorical, we talked about in the section before this, categorical data is data that could be separated into categories. So like males or females, that's a category, or math, English, science class, those are categories. So consider the following survey. 149 elementary students were asked to choose whether they preferred math or English class. The data were broken down by the gender. 42 males preferred math class, 47 males preferred English class, 35 males preferred math class, and 25 females preferred English class. A two-way frequency table is just a visual representation of the frequency counts for each categorical variable. The table can also be called a contingency table. So this is the same thing. A contingency table means the same thing as a two-way frequency table. Now remember, frequency is how often something happens. So we're really just making a table to represent this. So when I look at this data, if I'm going to put it in this frequency table, I'm going to take the numbers and put them where they belong. So 42 males prefer math class. So I'm going to males, math class, 42. 47 males prefer English class. So males, English, 47. 35 females prefer math class. Females, math, 35. And then 25 females prefer English class. Females, English, 25. Then I can find the total of any. So do I know how many total males I had? Well, if I had 42 males that preferred math and 47 males that preferred English, then I had 89 males total. And then if I had 35 females that preferred math and 25 females that preferred English, then I had 60 females total. Now, how am I going to figure out how many total people liked math? The same way I did this way, I'm going to add and get totals this way. So 77 total people that liked math and 72 total people that liked English. Now, you might be saying, how do I know whether I add this way or this way to get this total? Good question. It doesn't matter. So I could either add this way or I could add this way, and either way I add, I will have 89 plus 60 or 77 plus 72. Both of those should give me 149. This is a really good way to check to make sure that you filled in your data correctly. The total frequency for any row or column is called marginal frequency. So that's for any row or column. Why do you think these total frequencies are called marginal frequencies? So you could think about this in a bunch of different ways. One way to think about it is they're in the margin of the table. Remember the margin, like in Microsoft Word or Google Docs or whatever, your margin refers to like the outside. So they are in the margin. They don't represent all of the data. They're just like one portion of the data. Joint frequencies are the counts in the body of the table that join one variable from a row and one variable from a column. So why do you think these are called joint frequencies? They join two categories together. So an example of that, if you need an example just so you can tell the difference between them, would be like males and math. So we're going to draw a box around all the marginal frequencies. So my marginal frequencies would be like this one, this one, this one, and this one. Like this is just for math, this is just for English, this is just for females, and this is just for males. So they are my marginal frequencies. But these, we're going to draw a circle around the joint frequencies, are my joint frequencies. So my joint frequencies are like they join two categories, like males that like math and males that like English, and females that like math and females that like English. Okay, continuing on. Frequency tables can be easily changed to show relative frequencies. To calculate relative frequency, divide each count in the frequency table by the overall total. So relative frequencies are going to be a percentage. Okay, that's my percent. To calculate relative frequency, divide each count from the frequency table by the overall total. So let's make this relative frequency table. So let's flip back and look for a second. So we're dividing by the overall total. So for this one, I'm going to say 42 divided by the overall total of 149. So 42 divided by 149 . So 42 divided by 149 is 0.281, and I'm going to round that to the to the thousandth. So this 8 is higher than 5, so it tells that one to go up. So 0.282. And then my females were 35 out of 149. Which is 0.235. That rounds up as well because of that 8 out there. My males that preferred English were 47 out of 149. You get the gist? Which gives me 0.315. So it's either a percent, you could leave it as a decimal, but it also could be written as a percent. So keep in mind, let's write it above it. This would be about 28.2%. This would be about 23.5%. This would be about 31.5%. Now, females that prefer English would be 25 out of 149. Which is 0.168 or 16.8%. And then I also can continue to do the same for these totals. I'm just always going back to this 149 down here. So this one was 89. I'll slide this over. I think you can still see it. Cool. So 89 out of 149. Sorry, my phone keeps locking. 89 out of 149 is 0.597 or 59.7%. And then 60 out of 149 is 0.403 or 40.3%. Now I'm at my bottom totals for math and English, 77 and 72. So 77 over 149, 72 over 149, and then this is going to be 149 because that's my total over 149. So let's figure out all three of these really quickly. Oh no. Sorry about that, guys. So 77 out of 149 is 0.517. And as a percent, that would be 51.7%. 72 out of 149 is 0.483. For 48.3%. And then 149 out of 149 is 1 or 100%. Now, why do you think that these ratios are called relative frequencies? Let's look at that first. They are relative because they depend on the total. So they're relative to the total. They depend on the total. Okay, so we're going to draw a box around the marginal relative frequencies. Remember, my marginal relative frequencies are these on the outside. They're in the margin. And then my joint relative frequencies are the ones that are based on two different categories. This table's a little bit more messy. Okay. So let's look at this data. So these percentages, like 28.2% and 31.5%, add up to give me 59.7%. And 23.5% and 16.8% add up to give me really close to 40.3%. But what happened here is we rounded just a little bit. And because of that rounding, it just threw it off a little bit. But no, actually, that's right. That's exact. Sorry. 23.5 and 16.8 would give me 40.3. And then 51.7 and 48.3 would give me 100. And then you could go this way as well to ensure that they all add up, because they should balance out to all give you this 100 down here. So interpret the marginal relative frequency for male students. So the marginal relative frequency related to the total for male students, okay, the males, they were 89 out of 149 is my marginal frequency, but then the marginal relative frequency is that 59.7% of students were males. Okay, interpret the joint relative frequency for females who prefer math. So females who preferred math, 23.5% of students surveyed Okay, so that's really all of these percentages are here for, is to help us compare to that total. So let's continue on. Really all section 10.2 is just a continuation of the same topic. It's just the further practice. So for 10.2, the relationship between two categorical variables, same exact title, just part 2. So let's look at the let's practice. A survey of high school students asked if they play video games. The following frequency table was created based on their responses. So we have males' responses, we have females' responses, and we don't have any totals here, but it's asking us to compute the joint and marginal relative frequencies. Well, first, let's find the total. So 69 and 60 is 129. And 65 and 85 is 150. 69 and 65 is 134. And 60 and 85 is 145. Then when we put these together, we have 179. Either way you go, you get 179. Okay, now compute the joint and marginal relative frequencies. So now I'm talking about my percents here. So if I'm looking for my relative frequencies, I'm going to divide by the total. And my total, I'm sorry, is not 179, it is 279. My bad. So I'm gonna refer back to that total in every single one of these. So I have 69 out of 279. Okay, this time I'm just gonna take it straight to a percentage. Oops, sorry. 69 out of 279 is 0.247. So as a percent, 2 places, 24.7%. 65 out of 279, 23.3%. 134 out of 279 is 48.0%. 60 out of 279 is 21.5%. 85 out of 279, 30.5%. 145 out of 279. I know this is probably boring to watch. You can fast forward through this and just do it yourself if you want, but make sure you do write it down. That would be 50. Okay, so this is a weird rounding situation. I just want to make sure you understand it. This 7 would round this 9 up to a 0, which would mean it would have to carry all the way over and round this up. This is the only time you round past the 1 place, but because this is a 9, it would end up being a 52.0%. So normally we don't kind of carry over with the rounding, just in that special case. So divided by 279, 129 divided by 279 is 46.2%. 150 divided by 279, 53.8%. And then together that would give me my 279, which is 100%. Okay, cool. So let's answer questions based on this. How many female students do not play video games? So we're looking at females who do not play video games. So that's 85. Female students do not play video games. So that's just asking for this that's just asking for this joint frequency. It's not asking for joint relative frequency, just a joint frequency. So if we need to specify what that is, so we understand, we can put that there. Excuse me. All right. What percentage of students interviewed were females who do not play video games? So the females who do not play video games was 85. So that's the 85 divided by 279, which we got, which gave us 0.305, which we then rounded to 30.5%. So this is the percentage of all students interviewed, not just the percentage of females. Now, it's not asking us to do this, but I do want us to understand a relationship here. If it was asking us to find the percent of females that did not play video games, instead of 85 over 279, we would say 85 over 150 because that's out of the total females. Okay, so if it asked to find like percent of what percent of the people who play video games are females, then you would go to the 134, the people who play video games, instead of the total. So make sure you read the question. If it's asking percent of people interviewed, then you're going to hear. But percent of females, percent of males, percent of people who play video games, percent of people who do not play, there's a difference there. Okay, so consider this frequency table, the one we just looked at. How many male students were interviewed? So I'm looking at males, total 129. Okay. One of the interviewed students is selected at random. What is the probability that a student interviewed is male? Okay, so one of the interviewed students is selected at random. What is the probability that the student interviewed is male? So there's 129 males out of 279 total. So the probability is going to be 0.462. Or again, you could give it as a percentage, 46.2% chance that it is a male. Which numbers in this table represent joint frequencies? So the numbers that represent joint frequencies are my numbers that were already here. So that would be 69, 60, 65, and 85. Which numbers represent joint relative frequencies? My joint relative frequencies are my decimal numbers or my percentages, however you want to look at that. So that would be 0.247, 0.215. It's the percentages in here. I'm just listing them as decimals first, and then we'll list them as percentages. 24.7%, 21.5%, 23.3%, and 30.5%. Okay? What percentage of the subjects interviewed play video games? So we're talking about all of the subjects. So the 279 is my denominator. The one number that do play video games is 134. And so that is 0.480, which is 48%. All right, moving right along, beat the test, and then we'll be done. A survey conducted at Ambidextrous High School asked all 1,700 students to indicate their grade level and if they are left-handed or right-handed. Only 59 of the 491 freshmen are left-handed. Only 59 of the 491 just read the same sentence. Out of the 382 students in the sophomore class, 289 of them are right-handed. There are 433 students in the junior class, and 120 of them are left-handed. There are 307 right-handed seniors. So let's just take this piece by piece to fill in this, because there's a lot of numbers, and we need to make sense of them. That's really what's helpful about a 2A table, is it just kind of helps you balance and make sense of everything. So first of all, we know there's 1,700 students surveyed. So the 1,700 is going to go in my corner down here. Okay, I know that the total of all of this is going to be 1,700, whether it's this way or this way. Now, the second thing that we're comparing here, so we have the right-handed, left-handed. The second thing we're comparing is the class. So I have freshmen, sophomores. Sophomore is a weird word to spell. Sophomore, juniors, and seniors. Okay, now let's go through what I know. So only 59 of the 491 freshmen are left-handed. So 59 of the 491 total. Okay, out of the 382 students in the sophomore class, 382 total sophomores, 289 of them are right-handed. Okay. There are 433 students in the junior class, and 120 of them are left-handed. there are 307 right-handed seniors. So right-handed seniors, 307. Okay, so we have a lot of missing data here. Do you have any ideas as to how we could find it? I hope so. So if we know that 491 freshmen if there are 491 freshmen total and 59 of them are left-handed. Well, if they're not left-handed, they're either right-handed or ambidextrous, and we're assuming that none of them are ambidextrous, which is ironic since that's the name of their school. We are going to subtract from that 491. We're going to subtract the 59 we already know and assume that the rest, the 432 that are left, all must be right-handed. Okay? Now for my sophomores, I have 382 total sophomores, and we know where 289 of them are. So we're going to subtract there as well and say there are 93 left that must be left-handed. My juniors, I have 433. Take away the 120 we already know, and I'm left with 313. Now, here's where it's a little tricky. We don't know a total for seniors, but we know that there were 1,700 total students. So if we know that there were 1,700 total students, then we can go back and subtract. We can add the freshmen. So we have 491 freshmen and 382 sophomores and 433 juniors, which means we know which class 1,306 of these students were. We could take that away from 1,700, and we're left with 394. So there must be 394 seniors. Now, if there were 394 seniors and 307 of them are right-handed, we could take that away, and we're left with 87 that must be left-handed. Then I can just add my rows here. So 432 plus 289 plus 313 plus 307 is 941. Okay. Then I have a choice. I can either add this or I could subtract from 1,700. So I'm going to try both to make sure I'm right. So 59 plus 93 plus 120 plus 87 should give me 359. And I could have gotten that same thing if I said 1,700 minus 941. Okay, so when I was adding up here, I think I made a mistake. Hang on just a second. Sorry about that. Okay, so when I was adding right here, 432 I must have mistyped, plus 289 plus 313 plus 307. This number should be 1,341. Somehow I missed a whole 400 in there. Okay, so 1,341, which means then 1,700 minus 1,341 does give me the 359 that I have here. So now my table's all balanced. So that's a really good example, even though it was my mistake, that's a really good example of how you can double check yourself with a two-way table. If I added this way and then tried to subtract from here just to verify this number, that number should be the same both ways. So that's a good fail-safe there for you. All right, almost done. What is the joint relative frequency for right-handed freshmen? So there are 432 right-handed freshmen out of 1,700 total students. If you divide that out, I'm not going to pull my calculator up for that one, it gives you 0.254, which is 25.4%. What is the relative frequency 491 out of 1,700 represent? So let's find 491. So that is my freshman. Compared to all students, or to the student body, however you want to word that. Okay. And then circle the smallest marginal frequency. Remember, my marginal frequencies are my edges, so the smallest marginal frequency is this one, which represents the left-handed. So the smallest amount of students were in just the left-handed category. Okay, that's it. If you have any questions, let us know.